Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at symptoms and causes of network problems. We'll be discussing physical layer troubleshooting, data link layer troubleshooting, network layer troubleshooting, transport layer troubleshooting with ACLs, transport layer troubleshooting with NAT for IPv4, and finally, we'll look at application layer troubleshooting. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. We're going to look at the layered approach to troubleshooting. We're going to look at the layers of the OSI model. We're going to look at some symptoms. We're going to look at some of the causes of these problems. Now, these are common ones. You may run into these, or you may have something completely different than what we're talking about. But these are the common ones that we typically see out in industry. So some of the symptoms: performance lower than baseline. Now, the first thing to know about this first one here, performance lower than baseline, is you have to have existing baselines. So you need to make sure you have these baselines and that you can compare back to them. And the most common reasons here include overload or underpowered servers, unsuitable switch or router configurations, traffic congestion on low capacity links, or chronic frame loss. Next one here we have is loss of connectivity. Loss of connectivity could be due to a failed or disconnected cable. We can verify it by doing ping. If you can't ping across it, it doesn't work. You have two routers, and if you try to ping across it, you don't have connectivity. Could be your cabling. It could be an intermittent connectivity loss, and it would either be due to a loose connection or maybe oxidization on those connections. Another thing to look at is network bottlenecks or congestions. Now, if a route fails, routing protocols could redirect traffic to suboptimal routes. You may not notice this right away, that there was a bottleneck, but knowing how your network operates, once again, going back to your baselines, you may be able to look at that. And this can result in congestion or bottlenecks in parts of your network. Another symptom is high CPU utilization rates, and this indicates that a device is operating or exceeding its design limits. You are at 100% utilization, always bad. Most of the time, your CPU utilization should be below 50%. Some people say below 70%, but it definitely shouldn't be 90% or above. If you have those problems, and if you don't address them quickly, the CPU overloading can cause a device to shut down, or it could even fail. And the last symptom here is console error messages. Now, these error messages are reported on the device console and could indicate a physical layer problem. And if you have a syslog server set up, they will hopefully be being sent to your syslog server. Console messages should be logged to your central server. That way you have a record of them, and hopefully you have some software there that will then notify you there's a problem. Some of the causes here at the physical layer include power related. And what you would do here is check the operation of your fans to ensure that the chassis has intake and exhaust vents are clear. A lot of times when those airflows get blocked, it will get overheated. Overheated will lead you to power issues. Another cause would be hardware faults. Faulty or corrupt NIC drivers. A lot of times upgrading your NICs, especially the driver and the software on the client end, is going to cause you problems. You have bad cabling, you have grounding problems. They can all cause network transmission errors such as late collisions, short frames, and jabber. Cabling faults. You look for damaged cables. And if you got a damaged cable, it's going across the floor and people are rolling over it with carts, you've got damaged cables. Improper cabling or poorly crimped connectors. If you're making your own, or if you're having your intern make your own, maybe they're not being as careful as they should, and the wires aren't connecting fully in there. Suspect cables should be tested or exchanged with known working cables. Another cause may be attenuation. Attenuation can be caused if the cable length exceeds the design limits for the media, so more than 100 meters for unshielded twisted pair, or when there is a poor connection resulting from a loose cable, dirty or oxidized connections. Another cause is noise. Noise is electromagnetic interference, and that can be generated by many sources such as crosstalk between the other wires in the cable or wires running next to it. If you run a network cable next to an electrical line, you're going to get interference from that. Large electric motors out in the machine shop, they're going to generate electromagnetic interference. FM radio stations, police radio stations. If you're looking at Wi-Fi, wireless phones that work in the 2.4 gigahertz, some microwaves cause problems because they operate in the 2.4 gigahertz. We have interference configuration errors. Now, this can include incorrect clock rates, incorrect clock sources, interfaces not being turned on. This can cause a loss of connectivity with attached network segments. We also can, down here, another cause would be exceeding design limits. And a component could operate suboptimally if it's being utilized beyond its specifications. If it's designed to only operate at 100% in bursts, but if it's always at 100%, that CPU could fail. And speaking of CPU, we also, another cause here could be CPU overload. You're always overloading your CPU, you're going to have issues. And symptoms here include high CPU utilization percentages, instant queue drops, slow performance, SNMP timeouts, no remote access, no DHCP, telnet and pings are slow or fail to respond. All different causes for that. And so that's the physical layer troubleshooting. I hope you're liking this episode on symptoms and causes of network problems. If you have the time, please leave a comment and let me know what you think about symptoms and causes of network problems. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When you're troubleshooting at the data link layer, there's several symptoms that you may run into. First one here is no functionality or connectivity at the network layer or above. Some layer 2 problems can stop the exchange of frames across the link, whether others only cause network problems to degrade. Network operating below baseline performance levels, frames can take a suboptimal path to their destination, but still arrive, causing the network to experience unexpected high bandwidth usage on these links because they arrived in not the best path. An extended or continuous ping can help reveal if the frames are being dropped. So you do an extended ping where it doesn't stop at 4 or 5 pings, but it continues to go on. You can see if your pings are dropping. We also have excessive broadcasts. Now, operating system use broadcast and multicast extensively. Think of the DHCP process. Generally, excessive broadcasts are the result of poorly programmed or configured applications, a large layer 2 broadcast domain, or underlying networking problems. If you're using specialized software that is not widely available, that was custom written for you, maybe has a small audience, they could be poorly written. And because it was poorly written, you could have excessive broadcasts because of that, depending upon the technologies and how it was written. And one of the last symptoms here at data link layer for our troubleshooting is the console message. Routers send messages when it detects a problem with interpreting incoming frames, encapsulation or framing problems, or when keep alives are expected but don't come. The most common console messages that indicate a layer 2 problem is a line protocol down message. Some of the causes you have here at the data link when you're troubleshooting is encapsulation errors. Occurs when bits placed in the field by the sender are not what the receiver expects to see. We also have address mapping errors, and that occurs when layer 2 and layer addressing is not available. Another cause is framing errors. Framing errors can be caused by noisy serial lines, an improperly designed cable, faulty NICs, duplex mismatch, or an incorrectly configured channel service unit, CSU, line clock. Last cause here would be STP failures or loops. Most STP problems are related to forwarding loops that occur when no ports in a redundant topology are blocked and traffic is forwarded in circles indefinitely. Excessive flooding. This causes problems because of the high rate the STP topology has to change. Symptoms at the network layer when troubleshooting include network failure and suboptimal performance. Symptom of network failure occurs when the network is nearly or completely non-functional, affecting all users and applications on the network. These failures are usually noticed quickly by users and networking administrators, and obviously critical to the productivity of your company. The symptom of suboptimal performance, these involve a subset of users, applications, destinations, or traffic. So just a set of yours. It's not the entire network. It's just a portion of it. Optimization issues can be difficult to detect and even harder to isolate and diagnose. This is because they usually involve multiple layers in our OSI model or even a single host. Determining that the problem is a network layer problem can take a lot of time. Causes at the network layer here include general network issues. Often a change in the topology may unknowingly have effects on other areas of your network. Now, to determine whether anything in the network has recently changed and if anyone out there currently is working on the network infrastructure, you need to know what your network looks like. And so baselines a lot of times help you with this one. Then we have connectivity issues. They check for equipment and connectivity problems, including power problems, environmental problems, layer 1 problems such as cabling, bad ports, and even connections to your ISP. Neighbor issues, check the routing table for any unexpected or missing routes. Look at your routing table, see if it is correctly. We have our topology database, and this will be if there's any problems with the routers forming neighbor adjacencies. You have several routers and 2 of them just don't want to connect to each other. They don't want to form their adjacency. Some of the causes here at the network layer could be general network issues. And this is often a change in the topology, and it unknowingly has effect on other areas of your network. Now, to determine whether anything has changed on the network recently, a lot of times you use your baseline. And then if there's anybody working on an interface, maybe you have somebody working on an interface that's going up or down, and that's causing your issues. Another thing here is connectivity issues. What you'd want to do is check for any equipment or connectivity problems, including power, environmental, and layer 1. And you would look for things like cabling, bad ports, or even connections to your ISP. Then we have neighbor issues, and you check to see if there's any problems with the routers forming adjacencies. That one router is next to the other, they're directly connected. Are they having problems communicating? And then we have the topology database. And what you'd want to do here is you'd want to check your table for anything unexpected, like missing entries or unexpected entries. And then finally, we have our routing table. And you want to check your routing table to see here if there's also anything unexpected, such as missing routes or routes that shouldn't be there. When you're troubleshooting at the transport layer, one of the things you should look at is your access control list. Now, some common misconfigurations for access control lists here is the selection of traffic flow. Selection of traffic flow is often the interface and the direction, making sure that you have those set up. Another one is order of ACL entries. Your access control list should go from specific to generalized. The more specific is at the beginning, generalized at the end. Remember that you have the implicit deny any or deny all at the end. When you are using your IP version 4 addresses, make sure you're using a wildcard, not the subnet mask. Subnet mask and wildcards are basically the opposites of each other. Ones are zeros and zeros are ones. So make sure you're using the wildcard, which is usually zeros followed by one. So like 000.255 would be a wildcard mask. We have our selection of transport layer protocols, and it's important that only the correct transport layer protocols be specified in your access control entries in your access control list. Source and destination ports, ensuring that the correct inbound and outbound ports are specified. Use of the established keyword. The established keyword applied incorrectly can provide unexpected results here. And the last one here is uncommon protocols. Misconfigured access control lists often cause problems for protocols other than TCP and UDP. Another thing to look at when you're looking at layer 4 transport layer and you're doing your troubleshooting is NAT for IP version 4. Some of the common interoperability areas that you're going to have issues here is the bootp and DHCP. The DHCP request packet has the source IP address of quad 0, so 0.0.0.0. However, NAT requires both valid destination and source IP addresses. Therefore, bootp and DHCP can have difficulty operating over a router running NAT, either static or dynamic. DNS and WINS. WINS, once again, is the Windows version of the DNS server that is slowly disappearing. The DNS server outside of the NAT router does not have an accurate representation of the network inside the router. So if you're outside the router, you don't know what the inside looks at because you're using NAT. Configure the IP4 helper feature to help solve that problem. SNMP. SNMP management station on one side of the NAT router may not be able to contact SNMP agents on the other side of the NAT router. Configure the IP version 4 helper feature that can also help this problem. And finally, we have tunneling and encryption protocols. And these often require that traffic be sourced from a specific UDP or TCP port, or use a protocol at the transport layer that cannot be processed by NAT. And finally, we have troubleshooting at the application layer. Now, depending upon what application you're trying to use, you're going to need to take different approaches to this. Here's a list of some common application layer, and this is TCP/IP IP application layer. So layer 5, 6, and 7, session, presentation, application on the OSI model. And we can see in here, these are the protocols we use quite a bit. We have HTTP and HTTPS. We have our Telnet and SSH should be listed in here. We have FTP, TFTP, Secure FTP. We have SMTP, POP, IMAP. Those are all mail. We have our simple network management protocol, network time protocols, DNS. You have to have an understanding of all those so you can go in and troubleshoot the problems. It could be any one of those. DNS could affect how mail is delivered. DNS could affect how HTTP is. IMAP could be the reason why somebody is not getting their email on their mobile device. You have to have an understanding how all these fit together and then go in and be able to troubleshoot here at the application layer. It was my pleasure to provide you with this wonderful episode on symptoms and causes of network problems. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of my episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.